So we spend, a ton of time talking about firewalls, right?
Yeah.
Encryption keys.
The software side of things.
Exactly. But there's this other threat that, doesn't care about your password at all.
Raw
It's
electricity.
just raw, uncontrolled power. And that's what we're digging into today. We're doing a deep dive on a piece of hardware designed to stop that physical threat. It's the NTI SP-CAT5-6V CATx surge protector.
It's a really critical piece of kit that honestly gets overlooked a lot of the time. We forget that the cloud is still grounded.
Right. And we should be clear, this isn't the kind of surge strip you plug your computer into at home.
Oh, not at all. This is for the low voltage side of things. Think sensor accessories.
Like video surveillance cameras, access control system.
Exactly that. The spec sheet we're looking at calls out protection for, 22 AWG sensor cables, 12 VDC power, and RS-485 lines.
Okay, let's stop on that RS-485 for a second. That's kind of the nervous system for these industrial setups, isn't it?
It is. And because those cables can run for, huge distances across a facility.
They basically turn into giant antennas.
Huge antennas, yeah. A nearby lightning strike, not even a direct hit, can induce this massive voltage spike onto that wire.
And without something like this NTI unit, that spike just goes right down the line and boom.
Boom. Your expensive controller board is toast.
Which gets us to the really interesting part, I think. This three-stage defense system they talk about.
Yeah, it's not just a simple fuse that pops. It's way more active.
It's like a whole filtering process.
Yeah.
So for the RS-485 line, stage 1 clamps at plus or minus 90 volts. Now, wait a minute. If my electronics run on, say, 5 or 12 volts, isn't 90 volts still going to fry it?
It absolutely would, if that was the only stage. But you have to think of stage 1 as, the big burly bouncer at the club.
Okay.
Its only job is to take that massive high-energy hit from a lightning event, we're talking thousands of volts, and just knock it down to something manageable, something that won't vaporize the circuit itself.
It takes the initial punch.
It takes the heavy hit, exactly.
Yeah.
Then you get to stage 2.
Which is just a 3.3 ohm resistor. That seems kind of simple.
It seems simple, but it's clever. It creates this tiny, tiny delay. We're talking nanosecond.
A buffer.
Yeah, it's a buffer. It slows the surge just enough to let stage 1 do its job properly without overwhelming stage 3 all at once.
And stage 3 is the precision part then.
That's the precision. It clamps that remaining voltage all the way down to plus or minus 7.5 volts. It's usually a TVS diode, a transient voltage suppression diode. They're super fast.
So it's the final gatekeeper that catches anything left?
To a goalie that ever blinks. Yeah. And they use a pretty similar logic for the 12-volt DC power line, too.
Okay, so the internals are solid, but this thing is probably sitting outside next to a camera, right? It's got to be tough.
For sure. And it is. It's housed in this impact and weather-resistant polycarbonate enclosure. It's a solid little box.
And it uses screw terminal pairs for the connections.
Which I really prefer for this kind of application.
Instead of just plugging in a regular jack?
Yeah, because plugs can get loose. Vibration, temperature changes. A screw terminal actually bites down on the bare wire. You get a much more reliable physical connection.
Right. You don't want your protection to fail just because a plug got wiggled loose.
That would be the worst.
So let's talk about the cost of this fortress. What's the damage to the wallet?
NTI lists it at $128.
$128. That feels surprisingly reasonable.
Well, think about the alternative, right? You lose one high-end security camera, that's what, $1,000?
Easily. And if that surge travels all the way back to the head end and fries an access control panel...
You're talking thousands. Plus downtime, plus paying a technician to come out and reprogram everything. Suddenly $128 looks like really cheap insurance.
It's literally the hardware that secures your security hardware.
That's a great way to put it.
It kind of makes you think, though. We're always talking about smart cities and the flow of data. But we focus so much on the data part. How often do we actually think about the physical electrical integrity that keeps the eyes of the system open in the first place?
That's the thing. Without that raw physical layer being solid, the most advanced algorithm in the world is just code running on a dead circuit board.
Something to think about the next time a storm rolls in. That's our deep dive for today. Thanks for joining us.
Stay safe out there.